From the water we drink to the air we breathe, data scientists at Lawrence Livermore National Laboratory are using machine learning at every scale to help create a sustainable future. State-of-the-art machine learning methodologies are developed with the support of the Data Science Institute, the laboratory's hub for big machines, big data, and big ideas, which operates at the confluence of high-performance computing, rich scientific data sets, and groundbreaking technologies. Machine learning may sound futuristic, but Livermore scientists are already putting it to use in ways that impact and improve our everyday lives. For example, scientists are researching how nanotubes, structures thinner than a human hair, can be used to improve treatment processes for the water we drink, bathe in, and rely on for survival. By confining water inside of the tiny nanotube structures, one team is uncovering new characteristics at the molecular level.
What we find from the simulations and also machine learning is that we see all the understandings that we have in the common liquid phase of water sort of break down under confinement.
Under these extremely confined conditions, a new form of water has been observed that behaves in surprising ways at the molecular level, including forming structures that are closer to ice than liquid.
Water is much more complicated than we thought, and you think about that as a puzzle, right? So you have many water molecules, and there are so many ways to arrange that. And that's the reason why we really need to have a lot of data. And the only way to get the data fast and accurate is to use machine learning and data science.
AI-simulated water molecules help the team design more efficient nanotubes, which will lead to advances in filtration. Moving upstream from water molecules and nanotubes, machine learning is being applied to another problem affecting many lives in California and beyond: wildfires. The lab's data science experts have developed a machine learning method to help power company workers monitor and maintain power lines across California. Utility companies rely on this method, known as Grid DS, to prevent a dangerous phenomenon known as arcing. Arcing is a surge of electrical currents between two conducting elements, sometimes resulting in explosions which can spark wildfires. For power companies, prevention of something so unpredictable is difficult. That's where Grid DS comes in.
Wildfire in general is very tricky to identify, and because by the time if you identify it, you're too late, right? So you have to detect it instantaneously. That was the motivation of developing this, and how they can pretty much use this, so they can plug it into their tool set. Maybe have an open window that is Grid DS based and then identifying arcing, and they can just take that input from Grid DS and send someone in the field who can look into it and clear it out or see something is going on.
Thanks to AI and Grid DS, arcing can often be identified before it leads to catastrophe. As wildfires become more widespread and burn longer, they release massive outputs of carbon, a major greenhouse gas contributing to the rise in global temperatures. Livermore data scientists are using machine learning tools to address challenges associated with carbon capture and storage. A multi-step process that separates carbon dioxide from the air we breathe at the molecular level and transports it to a safe location for long-term storage. Understanding the effects of different carbon capture methods, like this facility featuring a 50-foot-tall tower, would benefit research across climate and sustainability-related fields. But simulation at this scale is not possible without the help of machine learning.
We trained the machine learning model in smaller scale. Since it is small, it's easy to generate data, tons of data. Because the reduced order model representing the small scale is so fast and accurate, now we can talk about the computational model which is possible for the industrial scale.
Each of the towers is made up of hundreds of individual carbon capturing units, which are easier for data scientists to simulate and scale up. By duplicating the real-world data from one scalable unit, the team can simulate not only one tower, but many, and in different locations across the country and beyond. With this information, predictions can be made about the facility's effectiveness removing carbon from the atmosphere and the impact on Earth's climate over time.
In some sense, human destiny depends on us, depends on the technology we are developing, right? And machine learning plays a big role.
For more information about machine learning and the Data Science Institute at Lawrence Livermore, visit data-science at llnl.gov.